Yet you can't solve this without pausing the video. So let's see such kind of numericals with gigantic expression and brand new identities. Given cos of x minus y, cos x and cos x plus y are in harmonic progression, find the value of cos x dot secant of y by 2. So I have to adjust the LHS accordingly. So I would be solving the equation more interestingly. Let's see. Given if A, B, C is in HP, then B is equal to 2AC divided by A plus C. That's the thing. So here B is cos X and A is cos of X minus Y and C is cos of X plus Y. Okay. While solving, you solve it based on the identities which we saw earlier. 2 of cos X cos Y. Everything deals with the identities which we used earlier. So cos of X minus Y plus cos of X plus Y is nothing but 2 cos X cos Y. Why? Because cos of X minus Y would give us cos X cos Y plus sin X sin Y, and cos of X plus Y would give me cos X cos Y minus sin X sin Y. So plus and minus cancel, of all those sign ratios would get cancelled, and we would end up getting cos X cos Y, which is equal to cos X. So I have cos X already on my LHS, and I have to adjust such that I would end up getting secant of Y by 2 get multiplied along with cos X. So I have to modify the equation accordingly. So use the identities versatile. Cos square X minus sin square Y divided by cos X cos Y. Okay. So cos square X cos Y is equal to cos square X minus sin square Y. So I am just multiplying cos square X cos Y equal to cos square X minus sin square Y. Okay. Now 1 minus cos Y of cos square X. I'm just taking cos square X as common. Square X common, 1 minus cos Y is equal to sin square Y. I'm just making it positive and transferring this to the RHS and sin square Y to LHS. So I would get cos square X dot 1 minus cos Y is equal to sin square Y. Now I can adjust this well. Okay. Because cos square X into 2 sin square Y by 2. This is a very popular ratio. 2 sin square Y by 2 is equal to 1 minus cos Y. And which is equal to sin square Y. Now, also I can adjust this sin square Y as, cos square X dot 2 sin square Y by 2 equal to 4 times, which means 2 dot 2 sin square Y by 2 and cos square Y by 2. Sin 2 theta is equal to 2 sin theta and cos theta. So I'm just substituting that. It's actually 2 square. Okay. So just we should, in order to get secant square Y by 2, it should, the LHS should be 1 by cos square Y by 2. So just cancelling this and 2 and 2 square, we would get cos square x is equal to 2 times cos square y by 2, which means while transposing this to LHS, we would get cos square x dot secant square y by 2 equal to 2. So I've used sine 2 theta formula here. Really important to be noted. So this is first question and we got the answer as 2 for that. So second one, if alpha plus beta equal to 90 degree, which means they are complementary to each other, and beta plus gamma is equal to alpha, find tan alpha in terms of tan beta and tan gamma. Okay, interesting. So alpha plus beta equal to 90 degree, which means tan alpha and tan beta multiplied together, I would get 1. It's actually, there is a identity where you would be telling if alpha plus beta is equal to 90 degree, tan alpha is equal to cot beta. So cot beta when coming to LHS, it would be transposed as tan beta. Okay, so tan alpha, tan beta, when multiplied, you would get 1. This is a very important identity which can be inferred from this one. Then given beta plus gamma is equal to alpha. Beta plus gamma is equal to alpha. Beta plus gamma is equal to alpha, which implies I want tan gamma. So tan gamma is equal to alpha minus beta. So putting tan ratio on both sides, I would get tan of alpha minus beta. Tan of alpha minus beta is nothing but tan alpha minus tan beta divided by 1 minus tan alpha tan 1 plus, sorry, 1 plus, sorry, tan alpha gamma. So 1 plus tan alpha, tan of alpha minus beta is equal to tan alpha minus tan beta divided by 1 plus tan alpha dot tan beta. We all know that tan alpha and tan beta product is equal to 1. So I would get tan alpha minus tan beta divided by 1 plus 1 is equal to tan gamma. So 2 tan gamma is equal to tan alpha minus tan beta. And tan alpha is equal to tan beta plus 2 tan gamma. So this is the final equation. And they asked us to prove find tan alpha in terms of tan beta and tan gamma. And yes, we found the tan alpha in terms of tan beta and tan gamma. So yes, this is. Now moving on to third question. Third question is find the value of cos cube beta divided by cos alpha plus sin cube beta divided by sin alpha. If cos alpha, okay. So given equation is cos alpha divided by cos beta plus sin alpha by sin beta equal to equal to minus equal to minus 1. Cos alpha divided by cos beta plus sin alpha plus sin beta equal to minus 1. So we have to find cos cube beta plus sin cube beta. Find value of cos cube beta divided by cos alpha plus sin cube beta divided by sine alpha. So let's solve. Let us assume for our convenience cos alpha by cos beta equal to t, which means t mm, which means sine alpha divided by sine beta would be minus of t plus 1 or 1 plus t for our assumption. Just because we assumed it as t, so t plus sine alpha divided by sine beta is equal to minus 1. When t goes to that RHS, we would get minus of 1 plus t. Yes. So this is the basic equation. Then we could adjust sine alpha as minus of 1 plus t sine beta. Am I right? And we also know that cos square alpha and sine square alpha is equal to 1. So just substituting, we would get t square cos square beta plus 1 plus t the whole square. Okay. And we also know from this we could infer cos alpha is equal to t times of cos beta. From this 3 only we would be balancing. Okay. T square cos square beta plus 1 plus t square 1 plus t the whole square sine square beta equal to 1. So you have to adjust accordingly. Okay. After solving sine square, from this particular equation, okay, sine square beta is equal to 1 minus t square cos square beta divided by 1 plus t the whole square. Okay. Same way you would get cos square beta is equal to t square plus 2t divided by 1 plus t the whole square. Sorry, t square plus 2t plus t plus t plus 1 would give me 2t plus 1. Okay. So this is the equation. Now, this is sine square beta and cos square beta, what we have inferred. And we want cos cube beta divided by cos alpha, cos cube beta divided by cos alpha plus sine cube beta divided by sine alpha, which can be written as cos square beta into cos beta divided by sine alpha. Cos alpha plus sine cube can be written as sine square beta divided by sine beta divided by sine alpha. Okay. Now we can substitute these equations, two different equations, and you get like here t square plus 2t divided by 2t plus 1. Okay. Cos beta by cos alpha. Cos beta by cos alpha would give me 1 by t from 1. and sine square beta is 1 minus t square divided by cos square beta even there. So I should just substitute that also. And after substituting, I would get what I would get. I'll put by 2t plus 1 into 1 by uh, t plus 1. Okay. So we got this. And after solving, what you will get, let's solve. T plus 2 minus 1 minus t divided by upon solving you would get 2t plus 1 as constant. Like we would get cancelled. T and t plus 1 would get cancelled because it deals upon partial fractions. So while dealing with that, you would end up getting t and t plus 1 uh, getting cancelled, and you would get 2t plus 1 as the denominator, and you had to solve the numerator. And upon solving, I have skipped 2 steps and coming directly to the particular work. So you would get t plus 2 minus 1 plus t divided by 2t plus 1, which is nothing but 2t plus 1 by 2t plus 1. 1. So the answer for this cos cube beta by cos alpha plus sine cube beta divided by sine alpha is 1. Very interesting, right? Such kind of questions. Yes, it would be interesting while solving these questions. Now let's move on to the last question of this session. Prove that cosecant 2x plus 4x plus 8x plus 16x plus cosecant 32x is equal to cot x minus cot 32x. So here I am going to reveal one really interesting identity. Let's see. Given cosecant 2x, I'm just denoting its short form. 4x plus cosecant 8x plus cosecant 16x plus cosecant 32x as the LHS. Here we can substitute it using a famous identity which is called where cot theta by 2 is equal to 1 plus cos theta divided by sine theta. Yes, this is a representation of cot submultiple angle in terms of cos and sine. It's actually cosecant theta plus cot theta. So cot theta by 2 can be written as cosecant theta plus cot theta. You would be amazed why I am introducing this identity here. It's because I want RHS in terms of cot theta, and LHS is full of cosecant terms. So I would just substitute this in order to get that. Cosecant 2x can be written as cot x minus cot 2x, correct, from this equation. And cosecant 4x now can be written as cot 2x minus cot 2x minus cot 4x. cosecant 6x can be written as, sorry, 8x, 8x can be written as cot 4x minus cot 8x. Same way, cosecant 16x and cosecant 32x can be written in that particular form. Cot, 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 cot 8x, cot 16x. Just add all these equations as given in LHS. You would get cot x minus cot 2x plus cot 2x minus cot 4x plus cot 4x minus cot 8x plus cot 8x minus cot 16x plus cot 16x minus cot 32x. Just cancel this. Cot x minus cot 32x, which is RHS, hence proved. So far we have solved these 4 different problems, numericals, which are really challenging to solve without pausing my video. And yes, now we solved it. And now trigonometry won't be such a terrible problem to you guys. It would be really smoothly and easy. And you have to adjust the equation and use the identities properly in order to get the proof correct or in order to get the value correct. Yes, please like, share, and subscribe. Please do watch the video completely till last in order to gain some insights and more proof like this in future. Thank you. Please like, share, and subscribe.